get into it. We won't be holding everyone up too much. We got a good talk today. Turns out we build developer tools, but we also want to talk about how we build them. We are kind of a product that was born 2 to 3 years ago, and everything we do is basically based in AI, right? Small models to do specific tasks, large models to do conversational interactions, vision processing models for all that stuff. And we're going to show today, how we've built a world-class product that ships across macOS, Linux, and Windows to tens of thousands of daily and monthly active users. That's just, what a next-gen AI product looks like. So we're going to get into it. So real quick introductions. My name is Tsavo Knott. I am a technical co-founder here at Pieces and also the CEO, which is not super fun. As of late, we just closed our Series A, so the past 3 months was not much code and a lot of Excel and PowerPoint. So I'm glad to be here. We're doing another tech talk. We're going to dive in, but we're really excited about what we're building. And yeah, Sam is here with us as well. So Sam?
Yep, I'm the Chief AI Officer. I'm based out of Barcelona, so we really. Oh, there we go. Yeah, so
nice.
We really span the globe, right?
Yeah.
And with that comes a lot of challenges, and yeah, informs what we do with your workflow. Yeah.
Awesome. Well, let's get into it. Okay, so the main thing we're going to get into first is what we're building and why. And then we're going to talk about how we've layered, in a very thoughtful way, machine learning into every experience and aspect of our product. I think it is super important these days as people hear about generative AI and vision processing and all these capabilities that are out there to think about how do they compose into a product experience that makes sense, right? And so that's what we're going to show you. We also are building developer tools, which means that every single person here can use our product and definitely can use, we'll take the feedback from it, and we want to get your thoughts. So we're going to have some room for time at the end for questions. It's going to be a little bit of a technical talk. Sam's going to get into some of the challenges and nuances of bringing AI into production, be it small machine learning models or large language models at scale. We were one of the first companies in the world to ship Mistral, Phi, and Llama 2 across macOS, Linux, and Windows in a hardware accelerator regard. So Sam's an absolute beast when it comes to that. And yeah, we'll show you some really cool stuff that's coming up with Phase 3 and Phase 4 of where the product is going. Anything to add there, Sam?
No, that's about it. Yeah.
So let's start out with what we're building and why. Maybe some of you were in the main stage earlier, kind of gave a little teaser. But long story short, myself as a developer, I've been writing software since I was 16. It's almost a decade, 11 years now. I feel a lot of pain in the form of chaos, right? Especially as I navigate large projects, be it in the pillar of the browser, where I'm researching and problem solving, or in a ton of projects where I'm looking at this Rust project, this Dart project, this C++ project. I'm jumping around a bunch. And then, of course, our team, we went from 6 people to 12 people, to 26 people very quickly, and jumping around on cross-functional collaboration channels, right? And so for me, it was already painful a year ago, right? And it feels like it's getting more painful. Raise your hand here if you've used GitHub Copilot or some type of autocomplete tool to write code. Well, guess what? Every single person now can go from the couple of languages that they used to write, 3 or 4, maybe 5 if you're an absolute beast, to 6, 7, 8, 9, 10, right? Your ability to move faster, write more code in half the time in different languages is going up. But what happens when you increase in an ability to write a couple languages in a couple of different environments to now 5 or 6? Well, that's 5 times the amount of documentation, and that's 5 times the amount of pull requests that you're able to do, or the cross-functional teams you can work on. And so we're seeing this advent where the volume and velocity of materials that you're now interacting with, the dots to be connected, are fundamentally kind of hinting at how the developer role is changing in this era of generative AI, right? And so for us, we want to build a system that helps you maintain the surface area as a developer in those workflow pillars, the browser, the IDE, and the collaborative environment. And so this chaos, how can we distill it down and make it a little bit more helpful, a little bit more streamlined for you throughout your work in progress journey? So I'll kind of power through some of these other slides. Maybe it's hard to see, but how many people, this is what your desktop looks like at the end of a workday? Lots of browser tabs, lots of IDE tabs, maybe GChat's open or Teams or Slack, right? That's what chaos feels like. And then you close it all down because you're like, I want to go home and drink some tea. And then you wake up the next day and you're like, oh shit, it's all gone, right? And where do I get back into flow? So that's what we're talking about, developer chaos. And so in reality, it kind of starts to feel like there's so much to capture, so much to document, so much to share, and there's not enough time, right? And so how do we do that for you in a proactive way? How can we make these experiences where it's like, I found this config, it's super important, I changed this implementation, but I didn't want to lose the old one, or here's a really great bit of documentation from a conversation I had, just fire and forget and save that somewhere, right? And have that somewhere be contextualized and fully understand where it came from, what it was related to, who you were talking to about that material, and then maybe give it back to you at the right time, given the right context. And so what we're talking about here is the work in progress journey, right? Most of the tabs you interact with a day, most of the projects you have, most of the messages that you have inside of GChat or Slack, all of that is lost, right? You maybe capture 10% in your mind. And then that's why, as a developer, our job is to half remember something and look up the rest, because we simply cannot capture all of these important context clues and these dots. And so, we're kind of like in this era now where that stuff doesn't have to be lost. We have machine learning and capabilities that can capture this stuff for us. So that's what we're going to get into. And just to put it simply, we're talking about an AI cohesion layer, right? A layer that sits between the browser, the IDE, and the collaborative space and says this is related to that, and that is related to, XYZ. We're going to capture that and save that for you. And then can we give it back to you, given that same context at the right time? So phase one was really simple. It was a place for humans to save, right? And this is our first principle, fundamental truth. People need to save things. As a developer, oftentimes you don't realize you should have saved something until you realize you didn't save it, right? And that's kind of really painful if your job is to half remember something and look up the rest. So we want to make a really, really great place for people to save things. And that was phase one. That was roughly 2 years ago. So this is kind of like an AI-powered micro repository. I'll do a quick live demo here, where effectively when you save something, all that stuff that you didn't want to do, but you should have done to organize it, so tags, titles, related links, capturing where it came from, who it's related to, all of that, we want to do that with AI. And that's what we started out doing 2 years ago. And so I'll just do a quick example here. Sam, maybe if you want to hold that for me. And Sam's about to get into the tech on this as well. And by the way, I'm not even lying. Look at my tabs that I have open right now. Just like 50 tabs, docs, GitHub, the whole 9 yards. Got my email, everything like that. But I wanted to feel natural, right? I'm not up here with, just a couple of tabs. Like I'm in your workflow every single day. Same deal as a technical co-founder. But let me go ahead and show you this. Maybe you're on, open source, right? And you're looking at an image picker implementation. So I'll kind of show you what this looked like before. You're here, you're checking it out. Maybe I'll use this, maybe I won't. I don't really know. But I'm going through the docs and I'm like, okay, I want to capture this. So this is what it looked like before. Maybe you go to your notes. I don't know, maybe you use text files or something way more primitive. And you paste it in there, right? It's not capturing the link it came from. You're not titling it, tagging it. It's going to be really hard to find this later, whether it's Google Docs, Notion, you name it. So a couple of years ago, we said, can we build a product that has AI capabilities to do a little bit more magic for you, right? So we're going to go ahead and we're going to grab that same code snippet. And by the way, I have very limited Wi-Fi, so I'm actually going to do this in on-device mode. Sec. Here we go. We're going to do this completely on-device, and I'll go ahead and so what I just did there was I switched the entire processing mode to on-device to give you an idea of what this Edge ML looks like. So that same code snippet that's on my clipboard, I'm just going to go ahead and paste that into pieces, and you're going to notice a couple things. Maybe it's a little dark, so I'll switch to light mode. Oh, classic. If Mac's in the crowd, we got some buttons. But either way, what you see there is I just pasted that bit of code, and it right away said, hey, that wasn't just text, that was actually code. This is using on-device machine learning. And it also said it wasn't just any code, it was dark code. But there, we took it a step further. So that title I was talking about, it's an image picker camera delegate class for Dart. And then if you flip it over, you're going to see there's a whole bunch more enrichment as well. We gave this thing a description. We're giving it tags and suggested searches. And we're also going out to the internet and aggregating related documentation links. So when you save something, we're pulling the outside world in to make sure that stuff is indexed and contextualized. So I can say, hey, this image picker is highly related to this bit of doc right here on the animated class. And so that's the power of machine learning. Was I just took a paste from what it looked like 4 years ago into my Notes app, and I pasted it in pieces, and instantly, with no internet connection, it enriched it, right? It said, here's all the details, the metadata that you're going to use for organization and for search and for filtering and sharing later on. But it also took it a step further and said, here are the things that it is associated with, the people, the links, the docs, etc. So we're going to get into that a little bit, and that's just super simple paste. There's a whole lot more to pieces that we'll talk a bit more about shortly, but let's keep it rolling. So, Sam, can you tell us a little bit about how that happened? What was going on there?
Yeah, for sure.
Take us away.
So, one of the big challenges we faced basically was this happened incrementally, right? So we started off by classifying code versus text, then language classifying, then tagging, then adding a description, a title, all the rest of it. And once we had all these models, effectively what we had were 7 different architectures, each reliant on their individual training pipeline, each needing separate testing, optimization to put into production, and all the rest of it. And so one of the sort of key challenges we faced there was once you have all these models, how do you deploy those across these different operating systems? Especially when you're training in Python, you're not deploying them in Python if they're on device. And so we were really lucky. We sort of hit this problem just as the whole Onyx framework kind of started stabilizing and being really useful. Eventually we plumped for that. This of course had a lot of challenges, right? So you're training 7 different models, each require different data. So that's like a huge overload on sort of cleaning, preparation. It doesn't scale well for local deployment. You know, we were sort of creaking at 5 models. By the time we got to 7, things were taking up a lot of RAM. Things are getting quite intense. And it's also super slow and expensive to retrain and to train these models, right? Each one's working on a separate pipeline. We're using CNNs, LSTMs. There's not much pre-training happening there. And so that was super challenging. And then, one of the sort of solutions around this, well, it came with GPT 3.5, right? Suddenly there's one model, it can do all of these tasks. Great, solution, done. We can wrap GPT, wrap a cloud model, get all this meta information, fantastic. The only problem is the LLMs really are too slow, right? What you saw there was 7 models executing like that. You can't do that with cloud calls. Yeah, even if just like that over the network costs, it's not going to happen. And so what we saw when we integrated LLMs was this whole experience became super slow. And also these cloud models, they're fantastic general learners, but they're really not there for coding, for your normal coding tasks, right? I think I was reading a paper a couple of weeks ago using GPT-4 for Python coding tasks. So you had an issue, you gave it the bits of code it needed to change to solve the issue, and GPT-4, I think, managed 1.4% of these tasks. So 2 challenges: slow and not really there to be able to work with coding.
And I would add one more. Security, privacy, and performance, right?
Of course.
So our DoD users and banking users and things like that, they can't send their code over the wire and back, right? So there was a huge thing around, air-gapped systems that are able to do this on device, right?
Exactly. And so we were looking for ways to take this sort of experience you have with the large language models, which is very nice, right? If you're generating tags, you're generating descriptions, you get really nice stuff back. We were trying to take that and put it locally, serve it on device. And one of the techniques that really helped, and again, it was super fortuitous, I think we were searching around for this, and I think maybe 10 days after we'd fully realized the problem, this low rank adaptation paper came out from Microsoft, which solved a lot of our problems. Now, lots of you maybe, who's heard of LoRA before? Yeah,
No.
there we go. So I'll run through basically what it does and why that really works for us when it comes to serving these models. So what you do, low rank adaptation, you take a general learner, so a large cloud model. You use that cloud model to generate data for your specific task. Doesn't have to be a lot of data. You then take a small model, something that executes very quickly, and you tune a very specific part of the weights in that model, okay? So we were using transformers, we were using a T5, excellent sort of foundation model. Specifically, we were using a T5 that had been trained extensively on code. So it was good at generating code, very bad at generating descriptions. We found if we took this general learner, used it to generate maybe 1,000 examples, we were then able to take this T5 trained on code and distill that behavior into that model. The way you do that is you focus on a particular part of the architecture. So you focus on the attention layer. Now, an attention layer, like there's lots of sort of analogies, I guess, to what it does, but it's basically just mean pooling, okay? And what you do is we parameterize that and learn these sort of weight parameters, which are basically a transformation on the attention layer. And then at inference time, you run inference as normal. When you get to the end of the attention layer, you just sum. So you sum these learned weights with the attention layer, pass it forward. And what you get is a highly performant task-specific learner from these sort of more generalized, from a more generalized one. And this had like several really sort of valuable features for us. So the first was no additional latency. So there are a number of ways you can take the knowledge from a large learner and distill it to a small one. This one was particularly nice because we don't have to pay any extra cost at inference. So that was number one. Second is training is much faster. You can get nice results with maybe 1,000 training examples, very nice results with sort of 5,000, 10,000, you're solid. And so what that meant is we were going from this training 7 different models with different data pipelines and on hundreds of thousands of examples, sometimes millions, and just reducing that to 5 or 10K, which is great for sort of speed of iteration, but it also means our engineers can train these models on their Macs. Yeah? So we're talking maybe 6-7 minutes to train one of these, locally, which just means we can move a lot faster, we can deploy a lot more, and we can retrain and update these models almost on the fly. The other really interesting thing is this works really well with other methods. So you can use LoRA. If you're not getting quite what you want, you can use sort of prefix fine-tuning models. But most importantly, we went from this situation where we were serving 7 separate models, which impacted like the size of our app, the memory usage, all the rest of it. And it meant we could just serve one foundational model, which is a small T5, I think came in at 90 megabytes, and then just add these LoRA modules on the way, which meant we could serve 7 different specialized tasks on the back of one foundation model with these modules. And so, that just meant we could move a lot faster, and it was a huge turning point for us. Phase 2.
Yeah. So phase 2 was, phase 1 was, okay, I can save small things to pieces, right? I can paste some code in there. I can paste a screenshot in there. It's going to give me everything we need, right? And so when Sam's talking about those LoRA modules, right, those embedding modules, we're talking about a module for titles, descriptions, annotations, related links, tags, etc., right? So we have this entire pipeline that's been optimized. And I would say to sum it up, the LoRA breakthrough was pretty profound for us. Then we moved on to another challenge. How do we generate code completely air-gapped or in the cloud, using your context of your operating system or a current code base or things like that, right? And a lot of people, how many people out there are hearing about Gen AI or AI features from your product teams or from management? Who's getting pushed to do that, right? You're going to be facing challenges, which are, which embedding provider do you use, right? Which orchestration, layer do you integrate? Which vector database do you use? Things like that. And these were all challenges that we kind of evaluated and took a look at early on. But we kind of, ended up at our approach where we want our users to bring their own large language models, right? So if you work at Microsoft, you can use Phi or you can use OpenAI, services, right? Or if you work at Google, you can use Gemini, and we'll do a quick demo of this. But from the initial idea that humans need a place to save, we moved on to phase 2, which was how do I conversationally generate or interact with all the materials that I have saved in pieces? And then can I use the things that are saved in pieces to ground the model to give me the relevant context. So when I go in and I ask it a question about a database, I don't have to say what database, I don't have to say what language, I don't have to say anything about that. It just understands my workstream context, right? And it understands even questions like who can I talk to on my team about this, right? Because pieces is grounded in that horizontal workflow context, excuse me. So I'll do a quick demo of this and then we'll keep it trucking along. So let's take a look at, what it means to have a conversational copilot on device across macOS, Linux, and Windows. And we're going to be, again, doing this in blended processing only. I'm offline right now, probably a bit far from the building. But one thing I wanted to mention super quick before I get into this is Pieces, it understands, when you're saving things. But what I was talking about is the additional context, the when you're interacting with things, right? So your workflow activity, when you were searching for what you were sharing with who, etc. That's kind of the when, which is a really important temporal embedding space for the large language model. But then also too, over time, you kind of begin to aggregate all of your materials. So all of these materials are used to ground both large language models and smaller large language models on device. So this is the things that I have already, but let me go over to Copilot chats. Something interesting here is that you can basically think of this as like a ChatGPT for developers, right? Grounded in your workflow context. And so I can come in here and you can see, it's going to give me suggested prompts based on the materials I have, but I'll do a little bit of a setup. I'll go ahead and we will do an on-device model. As I mentioned, you can obviously use your OpenAI models, your Google models, whatever you like, but I'll use an on-device model. And I'm going to use the Phi 2 model from Microsoft. So I'll go ahead and activate that one. And we're going to go ahead and just ask this a question. This is how you know it's a live demo. How to disable a naming convention in ESLint. Who's had to do that before, by the way? ESLint? Any pain? Okay, well, you're lucky. So let's see what the Copilot's going to bring up here. And this is using, I'm running on a MacBook Air here, an M2. We were really lucky to intersect the hardware space, starting to support these on-device models. And that's looking pretty good there. So it looks like we got a naming style with the rules. Ignore naming style check. Great. So when in doubt, if you're having linting problems, just ignore it. But besides that, that's a generative copilot right there, grounded, air-gapped, private, secure, and performant. And so we really think that this world of proliferated smaller models, kind of working in harmony with larger models is going to be the future, right? Integrated across your entire workflow. So everything you saw here in the desktop app, that is available in IntelliJ, in VS Code, in Jupyter Hub, and Obsidian, and all of our other plugins, but definitely worth a try. All right, and we'll get back to the tech. Just want to show you how this stuff actually looks, all the crazy stuff that Sam says. How do we actually productionize that? So, by the way, large language models, little cowboy hat joke there. I don't know if that's true or not, but cool. Sam, you want to take us away?
Yeah, for sure. I guess what you saw there's a couple of things that are sort of fundamental, right? So the first is you need to design a system that's isomorphic across cloud models and across local models, which is super challenging, right? So you need something that's you're going to be able to plug into any model, basically because the entire model space is moving so fast. If you don't do that, you're going to be locked in and left behind. The second thing is you need to take full advantage of the user system, by which I mean you've got to use any native tooling, you've got to use any hardware acceleration. This should say GPU. Sorry about that. And then finally, you need a system where you can pipe in context from anywhere, right? I don't know about you, but a lot of the AI products out there, you're sort of stuck within one sort of ecosystem or one application. And what we wanted to do was really break that, right? So we're a tool between tools. We want to enable you to be able to add context to your AI interactions from absolutely anywhere. And so, yeah, these were our sort of design principles, I guess, when it came to the Copilot. Yeah. So how did we do this? Well, it was a sort of emerging ecosystem, I guess, when we got into this. We looked at Onyx Runtime, which was great, but really didn't have the tooling to be able to run like a vast selection of models. And so in the end, we settled for TVM, mainly because this sort of abstracted away a lot of the sort of hardware optimizations. Specifically, we used MLC. I don't know has anyone used MLC or TVM? Right, this is your go-to. If you want to deploy a local model, this is really what you want to use. Yeah, and so MLC was great because it's open source. And a lot of the work here, when you're compiling a machine learning model, is designing specific optimizations for certain operations across a wide range of hardware. And that's something that's almost impossible with a 4-person ML team. And so, yeah, leveraging open source there was fantastic. And then this is all in C++. And so then we've got to get it into Dart. And so, yeah, fortunately, excellent tooling in Dart to do that. We were using the FFI to handle the sort of integration into the app. And then you've got this thing, right? So we know these large language models, if you want them to perform well at a specific task, you have to put a lot of effort into your prompt, right? That's true. That's just a fact. And you need a way to slam context into that prompt as well, right? The only thing is, if you're prompt engineering for a specific cloud model, that's just not gonna do well across specific local models or even other cloud providers. Okay, and so we really needed to build a system that allowed us to dynamically prompt these models based not only on what the model was, but where the information was coming from. And so, yeah, we built that out. We also wanted to sort of integrate multimodal data, right? So a lot of your information is in text, but I don't know. When I was learning to code, I watched a lot of videos. My team insists on sending me screenshots of code, which is super annoying, but there you go. And so what we wanted to do was take away the pain there and just allow you to add video, add images to your conversations with any of these models. And so we did that using fast OCR. We initially used a fine-tuned version of Tesseract. I don't know if anyone, Tesseract, does that ring any bells? Yep, super nice, open. Well, it's not very nice at all, actually. But it's available. It's a super available OCR system. We pushed that about as far as it could go for us. And so now what we do is we've moved a little bit away from Tesseract and more to utilizing the native OCR you've already got on your system, which at the time seemed like oh, great, out with Tesseract, this sort of clunky system that's been developed across, I think, 2 decades. I think it was 1996 that it came out. And yeah, let's use your native OCR. But obviously, that's not as simple as it sounds. Yeah. And so that had its own set of challenges. But yeah.
Oh, okay, we're on that. Excellent.
There we go. Okay.
Well, yeah, real quick on the Tesseract. Who in here uses Linux? Okay. All right, Sam, we're going to have to figure that out.
Yeah.
So what we're talking about next is basically the evolution of our product, right? So we talked about phase 1. Humans can save to pieces, and pieces is going to enrich that, index that, make it searchable, shareable, and all of the like, right? Phase 2 is you're going to move into this generate, iterate, curate loop, right? We're using conversational copilots to understand and explain and write code, grounded in the things you have saved. And now we are moving into phase X, or really phase 3 and phase 4. We've just closed our Series A, but let's show what all this is about. So you guys are some of the first in the world to check out this crazy stuff that we're about to release. Before it's even on TechCrunch or whatever, we'll see. So we want to build systems that are truly helpful, right? Systems that you do not have to put in all the energy to use, right? You don't have to memorize what this button does and what this does and so on. We want systems that are fast, performant, and private, that feel like you're working with a teammate, right? Feel like, here, we know you're going to need this. You're about to open this project. You're about to talk to this person. You're about to open this documentation link. Can we, based on your current workflow context, give you the right things at the right time? And so the other thing, too, that we want to talk about is I don't want to build a 100-person integrations team. There are so many tools that developers use out there every single day. Building and managing those hardline integration pipelines is a really difficult thing to do. And then standardizing those data models, piping them into the system, and so on. So we've been spending a lot of time in the past year and a half on some in-house vision processing that runs completely on device, is extremely complementary with the triangulation and the large language models that process the outputs. But it allows us to see your work stream as you do, right? Understand who are the people you are talking to? What are the links you're visiting, right? What are you doing in your IDE? What's actually changing? And by the way, this is the same exact approach that Tesla took with their self-driving, stuff. Is those cars, they run on device. They see the world as you do. They're not designed to hardline program every rule for every country, for every driving scenario, right? So we wanted to say, how do we scale very, very quickly across all the tools, both in an air-gapped environment or connected to the cloud? And then from there, can we truly capture and triangulate what's important? And that's hilarious because this is straight from our Series A pitch deck. It says for designers and knowledge workers. We're talking about developers today. That's hilarious. Anyways, so Sam, do you want to, I kind of touched on some of these, but that said, do you want to add anything else here?
No, I would say though that something that's super important, obviously, when we're deepening your workflow is we need to stop you from surfacing any secrets, any of that information. And so, I'd say like a big component of this is basically filtering and secrets removal and giving you the ability to run it completely air-gapped on device.
That's right. I mean, just like the human brain, you take in so much more than you actually process. The job is to actually filter out 90% of the information and capture and triangulate and resurface the relevant 10%. So that's what kind of Sam's talking about. And so there's a lot of machine learning and high performance models that are involved there just in the filtration process.
But it's not just machine learning, right? So I don't know about you, but I'm sort of fed up with interacting with AIs through a text chat. I think there's so much more room for innovation around how we interact with these models beyond just assuming that that's the best way. And so like part of this is really exploring that, right?
Yeah. I would say the joke I make to investors is like we went from a couple keywords in a Google search bar and then like opening a link and scrolling to like now full-blown narratives in ChatGPT, just trying to prompt and reprompt and dig it. So I feel like it's become a bit more verbose and laborious to use these conversational copilots. And we think that, the way they're going to be integrated into your workflow is going to be different, right? They're going to be more heads-up display or autocomplete-esque systems. So that's what we're going to show you. Sam, do you want to hit on anything here?
I think we've done it.
Okay,
that's good.
Great.
Yeah.
Well, let's do a quick demo here. So the first one, which is going to be pretty awesome. Hopefully we can see some of this. Basically, I'm in my IDE, and Sam, you could probably talk through some of this as well. This is your demo, so.
Yeah, for sure. Let me remember. This is. So this is my workflow. Basically what I'm doing is I'm just moving between windows, hopefully.
This is how you knew I was offline during the demo, but yeah.
Yeah, there we go. So I'm just doing a bit of simulation here. So this is a super early proof of concept. This is from a while back. But basically what we're doing is we're just moving between screens. To be able to do this previously, we'd need, I think, 4 integrations. You need one for the IDE, one for the chat, one for Notion, and one for GitHub.
Let's see if I can switch to the hotspot real quick. There we go, T3 for the win. And by the way, that's why you need on-device machine learning, because if we can't load a video, how do you think we can do all the processing in real time for you? It's not gonna keep up with your workflow. That would be an absolute nightmare. All right, here we go.
Yeah, great. So what's happening here is we've skipped around the workflow. We've captured the information you've seen specifically from the active windows. And basically what we're doing is we're using your activity in your workflow as an indicator of what's important, okay? So key here is we're not capturing everything, we're just capturing what you're looking at. And then we're adding it in, here's super simple use case, we're adding it in as context to part of the chat. And what that enables me to do is just ask, okay? So I'm at the end of the day, Dom's hitting me up about his PR, and I'm like, right, so I have no idea what that's about. Type in, could you tell me a little bit about what Dom's PR is all about? And yeah, there we go. Follow up, what are the specific changes? And it's all there. And so this really sort of highlights one of the key things. I think one of our key principles is that AI is interesting. And, it's these large language models are very convincing, but without the actual context, the outputs are useless. When you give them that context, you can get these magical experiences where you can talk about your team and all the rest of it. And we decided to take that and push it further, right?
Yep. So I'll just add there real quick. The way this will actually kind of manifest is, in reality, you can go to your Copilot and you can say, give me workflow context from the last hour or the last 6 hours, right? Instead of adding a folder or adding a document or things like that, you're just saying, hey, I want to use the last 3 hours of my work stream to ground the model. And then you can ask it, what was Dom's PR? What was going on? What are the specific changes? In this video, you can actually see this real-time output, real-time aggregation, or real-time triangulation as Sam is just moving through the browser, right? In GChat, looking at research papers, looking at documentation. And over on the left here, I know it might be hard to see, but it's outputting the links, who you're talking to, the relevant documents, it's filtering a bunch of stuff. And so that will actually also be used to ground the model. So you can come in and you can say, for the last hour, what was I doing? But we think that those conversational copilots, as I mentioned, they're a bit laborious. And so what we really want to do is give you a heads-up display given your current context, right? So wherever you are, if you're in the browser and you're looking at a Webpack config, can we give you relevant tags that you can click on and expand? Can we give you snippets that you've already used related to Webpack? Can we tell you here, we know with a high level of confidence you're about to go look at this NPM package, or you're going to go check out this internal doc? Can we give you a Copilot conversation that you've had about this Webpack config previously? Can we tell you to go talk to Sam or someone on your team that's worked on Webpack? And also, can we point you in the direction of an in-production Webpack project? And I didn't have to do anything here. Pieces is on. It's running in real time on your operating system. And it's just giving you what you need when you need it based on your current context in browser, in IDE, in collaborative environments. I don't have to type out a sentence. I don't have to go search for anything. I switch my context. The feed changes. And so these are the experiences that we think are going to be really profound, not only for developers, but for a lot of different knowledge workers at large. Having the right thing at the right time. You look at Instagram, YouTube, TikTok, Facebook, every feed out there in the world is really good at giving you interesting content. Why can't we apply that to your work stream, to the materials that matter to help you move faster each day? So that's a little bit about the workstream feed. That'll launch later this quarter. And then, by the way, we've got some crazy enterprise capabilities that'll launch later this year. But I think we are at a wrap here. So we'd love to have you come talk to us. We got a booth. It has no words, but it's got a really cool graphic, so you can't miss it. It's black and white. And yeah, Sam and I will be around to answer questions and field it. Yeah.
Thank you.
Yeah. So I guess 5 minutes for questions. Nice. We'll throw that up.
Did you say that it was watching you scroll through a browser window?
Yes, that's right. In real time on device, no internet.
So it would see the URL that you might hover.
That's
but
right.
Was it seeing what you're reading also?
That is right. That's right. Yeah. In a really smart and performant way, by the way. Yeah, because that's a lot of processing. So we do a lot of cropping, active cropping. Yeah.
I just wanted to know if you could talk more about how you decided to subdivide the tasks into, I guess, from a larger model to smaller models? How did you know, like, because it's a lot of space running these models locally. So did these smaller models provide you with like more leeway for the tasks?
Yeah, you want to talk about this?
Yeah, I guess, well, it was one smaller model. I guess that's the key thing. So we went from 7 to 1. So that's a huge sort of saving in terms of memory and all the rest of it. In terms of what tasks we decided to focus on, I guess that was really informed by designing a snippet saving app, right? So all of these metadata that we generate is very much sort of keyed in to you being able to find the resources that you've already used, right? And so things that are useful to collaborate. So that's why we hit up links, we hit up like related people, descriptions, all the rest of it. And so I think it was almost those tasks are almost sort of we didn't design them per se, we already had them. Yeah.
Yeah, and I would add to that, there are constraints, right? Like what you want to do if you want to generate a description, there's a limit to how much memory you're using at that time. And then, if you can generate that description in less than 100 milliseconds, right? So we would look at the problem and we'd say, what is the probability we can generate a 2-paragraph description in less than 100 milliseconds? And then we work backwards to solve for those tokens per second outputs. We would work backwards to solve for, GPU, CPU, memory footprint, whether it's cold started, you turn it off, turn it on to free up that memory. So there's all types of challenges involved, but I think the LoRA, I think generating a description is the largest, but then generating tags, titles, those are all sub-problems of descriptions. So we executed that pretty well. Yeah. Other questions? All right, let's rip it.
When are we going to be able to use AI for like no keyboard, no mouse interactions to do our tasks?
Well, we're waiting on Neuralink, I think, or Apple Vision Pro. I'm not really sure which one's going to hit first, but I think that I think. Well, let me tell you, if I was thinking at the speed of OpenAI's output, those tokens per second, I'd probably be pretty bothered. So we need to get that way up. We need to make it efficient. I think that it is quite expensive right now to process all the data as we're just throwing it up at these large language models. It's kind of like the human brain is a quantum computer walking around and operating on 13.5 watts. Like we need to hit that level first. So I can't really give you the answer, but I know we're well on our way. Yeah. Yeah.
Just to add to that, like I love my keyboard. I don't think I'd ever want to be in a situation where I just talk to my computer. Yeah.
Oh yeah, we're getting there. At least heads-up displays.
Hey, so you showed how you can literally like watch what's being done.
Yeah.
Any way of going the other way around in the future, being like instead of just being in a tiny window, you have draw on top of the apps to show what buttons to click and what the definitions are.
Yeah, I think that it'll be really tricky, but I would say if we fail as building developer tools, at least we could like open source the system so robots could like order at McDonald's and see the screen and just, we know that button's important to click, like we're going to do that one, right? That's kind of what we're doing. We're like, what's the URL? What's the tab name? What's scrolling and so on. So we think that vision processing, is going to be really important. I mean, our eyes are pretty important for us. So we think that these systems need to be able to do that. And then if we could build a really great foundation on that, to overlay like recommendations of actions to take and things like that, that'd be pretty cool. But we'll get there. That's maybe like Series F or something. I don't know. Yeah. One more question. Yeah.
So if you're working with a machine 75% personal, 25% work, is this working that further?
That's exactly right. Our models, they strictly understand technical language. So if you asked it a question about poetry, it would not give you a good output. And so that's how we're able to detect if you're working on technical language or natural language. And then, the other thing too is our models are really biased towards code. We've trained them on a lot of code. So, I think that, our ability to, when you distill a model down, you have to be very specific in what type of environment it's going to perform well in. So when you take it outside of a technical language environment and you put it into a heavy natural language environment, the performance is capturable as in like, it's not helpful. So if you ask the Copilot about the bank statement, I mean, it might do all right, but we don't care about that. We filter all that out. Yeah.
Yeah, and I'd say just don't tell your employer you're using using your work laptop for 25% personal stuff. But I guess no. Seriously though, I think we get around this with a lot of clustering, right? So we sort of came to Copilots after we'd done a lot of work in embedding, clustering, and search, and so we find we leverage that work, and at the end of the day, you can run this all on your device. So if you're using that device half and half for personal and work, you feel free to use our Copilots half and half for personal and work. You know.
Cool. Maybe one or two more. Yeah, one more. All right, we'll do it.
Cool. So I'm trying to think of this in like the context of my everyday workflow. Let's say, for example, I've been using Pieces for 3 months. It knows exactly what I've been doing. It knows my Kubernetes clusters and all that. So do you have something in your roadmap where it interacts with Kubernetes, for example, where I say, hey, Pieces, remember that API that I built that has this CI/CD workflow in GitHub and is deployed to this cluster? Do that again. Is that something?
Yeah, I mean, we're really interested in human in the loop systems. I think you have a lot of work that's being done right now around these autonomous agents. I think that we see a lot of interplay between copilots, and so when we get into the operational kind of execution side of things, I think we're gonna just slow roll that a little bit before we say, hey, we know all the docs, we know all the people and everything like that. Like go out and kind of do it for you. I think we're quite far away from that, and we'll let GitHub take the lead there. But for us, I think just the stuff that you interact with as a developer, like that statement there, that's probably at least 30, 40 tabs worth, couple of conversations, and definitely like a Jira or GitHub issue ticket. So, all of those dots we want to connect for you. When it comes to executing, hopefully you're still the one doing that, because otherwise, if it's like fully autonomous, then we might really have to change the way we write code. But we'll deal with that later. Yeah. Cool. I think that's that. Awesome. Thank you, guys.